Västerås, 1947. Första Hennes-butiken. Hennes & Mauritz har funnits i nästan 70 år. Sorry, you're right. I'll take it in English. Because we are very international. Sorry. 1947, Västerås. Hennes & Mauritz has been around for 70 years. Going international in the 60s to Norway, buying Mauritz, going publicly 1974, expanding across Europe, having a great business model which is loved by thousands, if not millions of customers. 98, going on the internet. Year 2000, Fifth Avenue. 2004, over 1,000 stores worldwide. Today, almost 5,000 stores in approximately 70 countries with over 100,000 employees, affecting more than 1 million people with our factories. AI-driven retail. I wouldn't say it's easy to have one store. You need to be very good at what you do and understanding your customer. But it's easy to interact with your customer. Having tens of stores, it's starting to get difficult. Complexity rises to be relevant. Having thousands of stores across the world, can that be driven by humans? Or do you need help by AI to scale? My name is Errol Koolmeister. I'm the lead data scientist of H&M, and I love AI. And so does our CEO. This was 2016, when it became quite apparent that the market was starting to shift. When we started seeing more and more of the impact of the digitalization, where we, as a company and as people, started to go more and more online and started to really see that scaling a business model of physical stores became quite hard. So, where does H&M want to be as a company? Well, the ambition level is high, but I would assume that most of you work for a company that has a similar strategy or a similar formulation. So it's really about putting your actions where your words are. Our story started 2016 when Carl-Johan came to my manager, Arti, and asked him, what are we doing within AI? So Arti, my manager, he worked in business development, and he did what he was good at. He looked into the business. And the answer was, we don't do much in AI and advanced analytics. We are really good at some things. We have really good departments specialized in CRM, but we don't have it at scale. And we are not putting everything together. So that was the initiation of actually starting looking into this, doing the first POCs. Can we extract any type of value? And obviously 2017 and 2018, it became quite apparent that the use cases we picked and started working on, they worked. They were successful. We could put them into production and make money out of them. And that's what it's all about, acting really, really rapidly. If we, 2016, would have said, let's do a proof of concept. Let's see if this works, and then stopped. Because that's what's happened in 90% of the cases I've been involved with earlier. You stop. Then no value would be then extracted. But at H&M, that was not the case. They were thinking production already 2016, making it quite apparent that if we're going to do something, we need to do it big. So it's really about starting small, and I know you've heard this before, and thinking big and scaling fast. So what I'm going to show you in the next slide is really where we are in this journey today. We looked into about 6 different use cases. I think we have 7 now. And we started extracting the value. We started building things from it. And just to make it clear, we don't say AI use cases, because there is no such thing as an AI use case. There are business use cases. And what we do is that we're amplifying our business solutions with AI. And we cover the entire value chain. We, today, look at the big cases. Where can we be relevant? Looking on the scale and complexity of a company as H&M, 5,000 stores. Where can we be most relevant? The turnover last year was over 200 billion kroners. Do you know how much garment we buy? We make an impact with our AI use cases. All the way from looking at what is it that we're going to buy? When will we buy it? How much of it will we buy? And where should we place it? In what stores? And how are we relevant to our customers in all of this? So, as I said earlier, different stages of maturity for our use cases. At H&MxAI, we always talk about production. And this first part is a little bit more about our journey, but I promise you I'll talk a little bit about tech in a short while. So, if you look on our journey here, POC, pilot, and industrialization, and rollout, we actually have communicated this quite widely because we really believe that this is the way forward. We take our use cases and we take them into a proof of concept. And that's not so long at all. We have our data lake in place with data ready to go. So we can spin up virtual machines and do insights within notebooks. It takes a few weeks. We started up a use case a few weeks ago and we already have the first results. Our models already have a quantified business value. It's not realized yet because it's proof of concept. But we can identify, we can build, and we can almost act within a few weeks. And if that is successful, we can then take it to the next stage. So what we want to do is when we build in our POCs, it should be very, very easy for us to go to the next stage. How do we quantify it? How do we roll it out? And of course, we can't roll it out to the entire world at once. So we need to pilot it in a few markets to actually see, is the theory matching reality? It's very good to say, or easy to say, I have done an excellent model. On the training data, I have an accuracy of 98%. Doesn't mean anything unless you actually put it into production, try it out, evaluate your results. And then, of course, if it's successful in piloting, we roll it out. 70 countries, 170,000 employees, 5,000 stores. Lots of requirements on reliability. So, that was the first part. H&M. Now we're going to talk about my favorite topic of all time. AI in production. Because when we talk about AI, it is very fluffy. Many of the presentations you attend is AI will save the world, AI will do X, AI will do Y. But we need methodologies to enable us to rapidly go from insights into value. And I'm a tech guy. I love tech. And when I listen to presentations from some of the digital natives, they are also struggling with this. It is easy when you start out to do it in an isolated environment. But as soon as you try to go from this small insight into a larger problem, it is hard. So, some of the learnings then. This is one of my favorite pictures. I don't know how many of you that actually like these tech drawings. This is just high-level conceptual. And this is based upon a lot of discussions I've had with some of the latest tech providers. one thing we need to do and start realizing is data. Data is key, but it's also a pain. It's really painful. And what I've done in many of my use cases in the past is that we try to fix everything from day one. It doesn't work. It doesn't really work. That's why the concept of starting small, scaling fast is so good. Because you need to have a good foundation of data, right? But you also need to work in small, agile teams. I love the concept of microservices, because what that really entails is that you build it, you own it. If we provide our teams with a data model that's fairly okay, it doesn't give them everything they need, but maybe 80, 90%. And then everything they do on top of that, they maintain themselves. We give them potentially a golden record. What's a customer? That might need to be common across all use cases. But if you do any features or anything like that, you build it, you maintain it. And when you do those things, it's very important to have a process on how you do it. Because what we talk about in modeling is really about going from training data into a model and seeing these as separate processes. What I see in many of the use cases that doesn't really understand the complexity of going to production is that they treat everything as a seamless process. But it's not. It's really two different processes. One is you build your model, the other one is you apply your model. That's why you need to start thinking in separation. So model development is really about model exploration. And in the other slide I'll show you in just a second, I'm actually going to tell you a bit about the tools we use for this as well. Because we really like open source, we really like cloud, and we really think that you should try to enable as much as possible. This is not where your IP lies, right? Your IP really lies in how you apply it, how you take these different open source models and combine them into insights. How you do this process, that's something we want to share, and we want everybody to work in a similar way, because then it becomes easy for us to create new knowledge. So we really think about model exploration as our step one. And then when you have done your insights, going into a model implementation, how do you create these pipelines? How do I train it? And then obviously when this is done, training process. This is where your compute power lies. So when people talk about GPUs, this is where you put the GPUs in the model training aspect. And then of course the iterative process of tuning your models offline. And this is where the majority of the cost lies. And when you hear consultants, or when yourself set up big, large clusters that sit idle for 90% of the time, this is where you can save money. We did a little bit of analysis on what if we have our clusters up, not using them, and just go in and do insights from time to time. We could reduce costs with almost 90% by having on-demand clusters instead. So there's a lot of money to be saved in this. And then obviously looking into how do I serve my models. So building these serving environments. And then obviously offline versus online. There's a lot of discussions about this on the market. So majority of the use cases I come across are always, oh, we're going to do churn predictions, or we're going to do propensity models. These are just bulk scores usually. Majority of the use cases today are offline predictions. But the majority of presentations I attend, they talk about online serving. So there is a little bit of discrepancy still out there on how to handle offline versus online. And then after that, model monitoring, which is usually the hardest part. So model monitoring is you have your models in production, you're all dandy and you can go, but what happens afterwards? How do I keep track of my accuracy when it goes down? How do I evaluate, and how do I retrain? So having a process for that. So how do we handle these things? Well, we like to give our data scientists notebooks. We used to be very looking on Jupyter notebooks, spinning up clusters, handling all the integration, but then we just realized let's have it easy. Let's pick something that has AD integrations. Let's have a cluster that actually we can spin up and down on demand. Since we have separated data from compute, we are quite free on spinning up new things and accessing the data. So for a data scientist, their job should actually be in the first domain, the model exploration. They shouldn't do much more. And this is the problem. Most of the companies today believe that their data scientists will work across everything, but they are not data engineers. So when you tell a data scientist you need to be able to be an expert coder in Python and Java and Scala and all of the languages you can think about, you are scaring a lot of people off with a lot of good skills. But if you're giving them a notebook and access to data, you're enabling them to do great things. Because we need more engineers to build out these pipelines. So the next step on the implementation is lifting your models into a format that can be pipelined into something bigger. So I mean, enabling data scientists to just lift their models, because usually models are 1 or 2 lines of code. Feature engineering, on the other hand, that's another part. But that's I'm not even going to cover today. And then model training. What type of clusters do I need? Do I need GPUs? Or is Spark sufficient today? Do I have model tuning? So that might be an iterative process as well. And then obviously, you've trained your model, it's persisted. How do I serve it? Dockerization, enablement of these models to be moved around in a better way. And then obviously, if you're doing online serving, having some REST API that you can spin up and easily just communicate with. And then for offline model prediction, might be as easy as just a cron job, preferably not, but it's much easier to keep track of. And then end of the day, model monitoring. There are a lot of tools on the market that are provided, like ModelDB, open source from Yale, which is decent. But this is really still a gap, I would say. How do we maintain this complex pipeline and follow up on it? If I had a good answer, I wouldn't be asking you. So our approach is really about creating microservices. Why? Because if you work in a large, complex organization, and if you think that you will go in and create monolithic architectures with AI, think again. You will be stuck in a waterfall approach, which will take 9 to 12 months release cycles to get something out. But if you work in a microservice-based, agile type of way, you will be able to work independently in your team and create great services. Microservices will be data coming in, results coming out. That is your job as a data scientist, the algorithmic part. And then, of course, there's so many other things around it. What we say is 70% of the time it's business and processes. But if you focus on a data scientist, that's not where they want to spend their time, in business and processes. They want to spend their time with the algos and the tech. So if we can enable them to work in this silo, we can have business people driving the business and the processes. Specialization is key. I'm almost running out of time, but there are a few things I just want to end on a good note. H&M will be the next fashion leader within AI. What we are doing here today is that we want to tell the world that we do tech. We love tech, and I love AI. And also, what we're trying to accomplish, and that's where we want to meet a lot of you guys, is orchestrating an AI network across the world with our size. So if you want to have a chat, if you want to discuss a little bit more on how we can do this, just grab me or any of my team members. We're outside. And an important part with AI: do no harm, do good. And I started with a passion up here, and I want to end with one as well. Agile. The secret of success. There is no secret. Just keep renewing yourself over and over again, and you will be successful. My name is Errol Koolmeister. Thank you for listening.